Alright, welcome back. In this video we're going to learn how to construct the structural stiffness matrix, which is this S sub C. Now if you remember from a couple videos back, S sub C is actually composed of 4 different submatrices, okay? You have matrix, 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 matrix. And this first matrix is UU. This next one is UR. This one is RU. This one is RR. Okay, and then in this example we're actually going to learn what all of this means. Now, the structural matrix S, or the structural stiffness matrix S sub complete, is equal to the sum of I equals 1 to N equals 4, so 4 different element I's, starting at element 1, of all the values for the stiffness matrix I. Now, I'm gonna, let's see, what I'm gonna do here is I'm gonna write S sub complete, and I kind of want to show you what the subscripts UU, UR, RU, and RR mean. So, the way we label, and yes, this is going to be very big, very long. Again, if you know what's going on, you can skip past this part, or once you start getting the concept, you can skip past this part. But the way I label this complete matrix, actually before even labeling, we need to figure out how big this matrix is going to be. And this matrix, the size of this matrix depends on how many degrees of freedom we have. In our case, we have 10 degrees of freedom. That means this structural stiffness matrix is going to be a 10 by 10. And that means there's going to be 100 different values we need to find for this matrix. Now, we have the way we label the columns and rows is we start from the first degree of freedom and we go to the last in order. So unlike the stiffness matrix where we looked at each element and we did left to right, rotations, then verticals, we start from degree of freedom number 1 and we go all the way to degree of freedom number 10 in order. So we have 1, 2, 3 here, and then that's our unrestrained, right? So then we have our restraints 5, 6, 7, 4, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then on the side here, oops, we have again 1, 2, 3. Then we have 4, 5, 6, 7, 8, 9, 10. Okay, and the size of the matrices here, the 4 submatrices, depends on the types of degree of freedoms we have. So in this case we have 3 unrestrained degrees of freedom, and then the rest are restrained degrees of freedom, right? 4, 5, 6, 7, 8, 9, 10. So what I'm going to do is I'm going to partition this matrix in 4 parts. And the way I'm going to partition this is I'm going to draw a line between the last unrestrained degree of freedom and the first restrained degree of freedom, both for the columns and for the rows. In other words, I'm going to put a line between 3 and 4 because that's where the color changes, right? From restrained to unrestrained. So I'm going to put this here, and then I'm going to put a line here. And notice that this matrix here, S sub UU, is a 3 by 3 matrix, right? You have 3 columns here and then you have 3 rows here. And notice that all these values are in the green values, meaning they're all unrestrained degrees of freedom. And that's what the subscripts mean. You have UU, and the first subscript stands for the row, the second one stands for the column. So you have unrestrained, unrestrained, right? Unrestrained 1, 2, 3, unrestrained 1, 2, 3 up here. This next one is going to be S sub U R. Oops, U R. First one stands for the row, unrestrained. Second one stands for restrained, up here, right? 4, 5, 6, 7, 8, 9, 10. And so for the bottom one, you have S RU, right? Restrained 4, 5, 6, 7, 8, 9, 10 here on the side, the row. And then unrestrained 1, 2, 3 column. So this is actually a 7 by 3 matrix, right? And then finally you have S sub RR. And this stands for restrained, restrained, restrained column, or restrained row, restrained column, right? So let me actually erase this, and let's figure out how we're going to get 100 different S values. Okay, now that you know what each of the boxes mean. The way we start, or the way I do it, is we look at spot number 1. And spot number 1 is row 1, column 1. Okay? Row 1, column 1. And since we said up here that S sub C is equal to all the values of the stiffness matrix in that unique spot, right? Unique location of 1, 1. We add all those together from our 4 previous stiffness matrices, and whatever the sum is of those values, or just value, we place here in 1, 1. So let's do an example. This is S sub 1, 1. S sub 1, 1, right? Row 1, column 1. And so we look at our 4 previous matrices, and we look for all the values that are in location 1, 1. So we start here at K1, and we look for row 1, column 1. And this value is 1/6, right? And then we look at K sub 2. Is there a 1, 1 here? Well, yes, there is. There's a 1 here, and there is a 1 here. So that value is 2/9. Is there a 1, 1 in the third matrix? Well, no, there isn't. Is there a 1, 1 location in the fourth matrix? Again, no, there isn't. So the only 2 values here that are 1, 1 is this 1/6 and this 2/9. So if we add 1/6 and 2/9, S sub 1, 1, S sub 1, 1 is going to be 7/18. Okay, and for S1, so we figured out what S11 is. It's 7/18. Now we move on to the second column, first row. So we have 1, 2. Now we look at the matrices up here. We start with K1. Is there a 1, 2 here? No, there isn't. Is there a 1, 2 for the second matrix? Yeah, there is. There's 1, column 2. We have a value of 1/9. We look at number 3. Is there a 1, 2 here? No, there isn't. And for K sub 4, again, there's no 1, 2 value here. So the only value of 1, 2 is this 1/9 here. So then we plug in 1/9 here. We move on to the next one. 1, 3 is this location right here. So we look at 1, 3. We start with matrix 1, stiffness, right? K1. Is there a 1, 3 here? No. For number 2, is there a 1, 3 here? No. For number 3, is there a 1, 3 here? No. And K sub 4, again, is there a 1, 3 here? No, there isn't. So that means since there are no 1, 3 values, this value right here is 0. Okay? And if we do this for all the matrices, or for all 100 values, we're eventually going to come up with the S sub complete matrix, and that consists of 100 different values. Okay, so the next one you would do is, right, 1, 4. You look up here, you start with K1. Is there a 1, 4 here? Yeah, there is. There's a 1/12 here. And then is there a 1, 4 here for K sub 2? No, there isn't. For 3 and 4, again, there's only one location where there's a 1/4, and that's that 1/12, right? So you come over here and plug in 1/12. Okay, so you do this I guess 96 more times, and you should get all the values for this S sub complete matrix. We'll continue this example in the next video. In the next video, I'll actually have all these numbers filled out, so if you want to actually try to do the S sub complete matrix right now before watching the next video, feel free to do so, and you can probably check your answers with mine, see if they're right or wrong, and then we'll move on with the example. Alright, so see you in the next video.